All right, so like I said, you guys did 11.3 and 11.4 in the last lesson. We were just going to be getting through some of that Chapter 11 information pretty quickly, and now we're going to be going through most of Chapter 10 here for the last little bit of the school year. Depending on how quickly we can move through this, we might get into a little bit more besides Chapter 10, but for sure we'll be working on Chapter 10 here. So we're going to get started with Lesson 1, which is on circles and circumference. So the first part that we're going to be talking about here is different parts of a circle. Then we're going to talk about the circumference and how to find it, which for the most part should be some good review for you guys. So parts of a circle. A circle consists of all points in a plane that are a given distance called the radius from a given point called the center. So we always have the center of a circle, which is a point named by an uppercase letter, just like any point. And then the radius goes from that point to any point on the outside of the circle. A segment or line can intersect a circle in several different ways. So like I just said, a segment with endpoints that are the center of the circle and a point of the circle is the radius. So again, it goes from the center to any point on the circle. Then we've got a chord, which is a segment with endpoints that lie on the circle. So here, any segment that has two endpoints on the circle, so AE could be a chord, or BD could be a chord. Then we've got the diameter, which is a chord that contains the circle's center. So in this case, BD is both a chord and the diameter. So in the examples we're going to get into, they're going to ask to name the chords, the radius, the radii, the diameters. Again, the diameter will also be a chord, and the diameter is always twice as long as the radius. Now, when you name a circle, it is always named by the center point. So when we talked about triangles, we named a triangle something like triangle ABC. So that was naming a triangle. For naming a circle, again, it's always going to be named by the center point, so in this case F, but we can't just say F because that's just a point. So instead of putting a triangle, we're going to put a circle with a point in the middle. So this would be read as circle F. So I'm going to go ahead, I'm going to skip over theirs, and I'm going to go to one that we'll walk through together here. So first, name the circle. Each circle has only one name. It's only named by its center point. So again, we want to draw a circle with a point in the middle. And in this case, the center point is R. So this would be the name of the circle, circle R. Naming the radii of the circle. So we want to name every radius in this circle. So in this case, again, the radius goes from the center to the outside of the circle, so there's 4 of those in this circle. These are going to be named since it's a segment, it's going to be named by the 2 points that make up the segment. So the first one could be AR, and it needs to have the line over the top since it's a segment. Then we would also have XR, we would have YR, and we would have BR. So those are the 4 radii of the circle. Next, name the chords of the circle. So again, a chord is any segment that both ends lie on the circle. So here we've got 1, 2, 3, 4 chords on this circle. They would be named just like the radii. We would do it by the 2 endpoints with a line over the top. So we would have AB, XY, AX, and BY would be our 4 chords. Then the diameters, remember, is a chord, so it goes from one end of the circle to the other, and it has to go through the center of the circle. So in this case, we would have 2 diameters, which would be AB and XY. Now, talking about the relationships between the radius and the diameter. Again, the diameter is always equal to 2 times the radius, or we can say that the radius is equal to the diameter divided by 2. Again, this should be review for you guys. So here, find AR. AR is a radius if AB is 18 millimeters. So AB, the diameter, is 18 millimeters. The radius needs to be half of that. So it would be 9 millimeters. Next, find AR and AB. So we need to find AR and AB if RY, so we have a radius of 10 inches. So we need to find AR, which is also a radius. The radii will always be the same. So that'll be 10 inches. Then find AB, which is a diameter. So 2 times the radius, which would be 20 inches. And then the last one is AB congruent to XY and explain. So we have AB and we have XY. If we looked here, those were our 2 diameters. We would say yes. And the explanation would be that diameters are always equal. Now, I will tell you on your homework, make sure you read the directions carefully, because I'm pretty sure instead of saying name all the radii, all the chords, all the diameters, I'm pretty sure on your homework they only ask you to name one of each on these types of problems. So if you name more, awesome, you did some extra practice, but I'm pretty sure, read the directions carefully, I think it just says name one chord, name one radius, name one diameter. So those are the different parts of the circle. Next, we're going to talk about circumference of a circle. The circumference of a circle is the distance around the circle. So it's similar to if you had a square, you would be asked to find the perimeter of the square, the distance around that square. Here, instead of perimeter, we're using the word circumference. So for a circumference of C units and a diameter of D or a radius of R, there's 2 different equations we can use here. The circumference is either equal to pi times the diameter, or the circumference is equal to 2 times pi times the radius. Now again, those are really the same equation because 2 times the radius is equal to the diameter. Now a reminder here, when you're doing these problems that include pi on your calculator, if you have a calculator, graphing calculator, or anything that includes the pi symbol, on here you would press second, and then you would press the caret, the arrow up symbol, and you see that makes pi show up on the calculator. If your calculator does not have the pi symbol, go ahead and use 3.14 for your value of pi. I'm going to take a look at another calculator here real quick. Yeah, if you have one of these calculators like what I have in my classroom, these also have a pi button right here, which you wouldn't have to press second first, you would just press that pi button. So let's go ahead and get into some examples here. Find the circumference of a circle with the given radius or diameter, round the answer to the nearest hundredth. So again, circumference is equal to pi times the diameter, or circumference is equal to 2 times pi times the radius. So round to the nearest hundredth. If r, the radius, is 8 centimeters, then we would say the circumference is equal to 2 times pi times 8, which would be 16 times pi, which rounded to the nearest hundredth would be 50.27 centimeters would be our circumference there. Now let's go ahead and do another one here. Let's do number 2. Since it has a square root in there, this one's going to be a little bit different. So it tells us the radius is 3 times the square root of 2. So we would have the circumference, sorry, board's messing up. We would say for this one that the circumference is equal to 2 times pi times 3 times the square root of 2. Now I'm going to change the order that I do my multiplication here. If I do 2 times the square root, or 2 times 3 root 2, if you remember, you multiply anything outside the radical or outside the square root sign, so this would become 6 times the square root of 2. So our circumference would be pi times 6 times the square root of 2. So I'm going to do 6 times the square root of 2. Then I'm going to multiply that by pi, and I get my circumference of 26.66 rounded to the nearest hundredth. My label would be feet. So that would be my circumference right there. Let's go ahead and do one more. Let's take a look at number 5. Here we're given the diameter, so we're going to use circumference is equal to pi times diameter. So circumference equals pi times 1/3. So I'm going to go ahead and do 1 divided by 3, multiply that by pi, and I would get my circumference of 1.05 meters. So again, for the most part, review there, finding circumference, but throwing in a little bit of what you've learned this year with square roots and things like that. So now, the radius, diameter, or circumference of a circle is given. Find the missing measures to the nearest hundredth. So here, on number 7, we're given the radius. We have to find the diameter and the circumference. So if the radius is 4 centimeters, our diameter is 8 centimeters. Circumference, we can either do 2 pi r or pi times diameter. I'm going to go ahead and do the diameter of 8 times pi, which gives me a circumference of 25.13 centimeters. So we'll just walk through one more of these. That one, I was given the radius. I found diameter and circumference. Let's look at number 10. We're given the diameter. We need to find the radius, which is half of that diameter, so 7.5 inches. Then the circumference, which I'm going to do the diameter times pi. 15 times pi gives me 47.12 inches. So then the last thing we're going to do, it tells us to find the exact circumference of each circle. Now finding the exact circumference, if I go back up to here, I have, let's take a look at this first one that we did. We had circumference is equal to 2 times pi times 8, which really is the same thing as the circumference is equal to 16 pi. Now, anytime you're working in math, you have 2 options. You have either your exact answer or you have your approximate answer or solution. Now, in this case, the circumference is equal to 16 pi would be considered our exact solution because 16 times pi, nothing has been rounded. In this case, once we plug it into our calculator and round it to the nearest hundredth, this is what we would consider an approximate solution because it has been rounded, which means it is no longer the exact solution to the circumference of this circle. When you round, even if it's just barely changing the answer, it changes it from the exact to the approximate solution. So knowing what it means to find the exact solution, let's go ahead and find the exact circumference of each of these circles. So we have a triangle inscribed within this circle, and we know that it's a right triangle with legs of 5 and 12. We need to find the hypotenuse because that will give us the diameter that we need to find the circumference here. So to find that hypotenuse, we can use the Pythagorean theorem. So we would have 5 squared plus 12 squared equals x squared. That would give us 25 plus 144 equals x squared. 169 equals x squared. Take the square root of both sides, and we would get x equals, in this case, 13. So our diameter would be 13, so to find the exact circumference again, pi times the diameter, so the circumference would be either pi times 13, or I could say 13 pi, either way. Doesn't matter which way you write it because it's multiplication, so it'll always be the same. But this would be our exact solution. We wouldn't actually plug it into our calculator because then we'd have to round, which would give us the approximate solution. So that's our exact solution right there. Circumference is 13 times pi, or pi times 13. Now I did forget one thing in my answer, and that's my label, centimeters. Let's do one more here. This one, we need to find that hypotenuse again of the triangle in order to be able to know our diameter. Now, since it's a right triangle, there's two different ways that we can go about finding that hypotenuse here. The first way is that if this angle is 90 degrees and these two legs are both the same, if the legs are both the same, they're congruent. That means the opposite angles are congruent, which means that these both have to be 45-degree angles. So if these are both 45-degree angles, if you think back to when we talked about 45, 45, 90 triangles, your legs are both x, your hypotenuse is x times the square root of 2. So in order to find our hypotenuse here, we're going to take one of those legs, the square root of 2, and we're going to multiply it by the square root of 2. Now this is the same as the square root of 2 squared, which those cancel, and you get a length of 2. Now the other way that we could have found that is what we did over here, the Pythagorean theorem. We could do the square root of 2 squared plus the square root of 2 squared is equal to x squared or c squared. Here again, square root and square cancel. We get 2 plus 2 equals x squared, or 4 equals x squared. Take the square root of both sides, and x equals 2. So now that we found that diameter of 2 centimeters, we can say that our exact circumference would be 2 times pi centimeters. And that would be our answer there. So that's what you guys are doing today. A little bit longer assignment than we've been having, but again, a lot of it is just naming those different parts of the circles. And on your homework, again, you only have to name one of each part. So you should be able to get through this assignment pretty quickly. It is going to be due tomorrow on Friday. And then we're going to have a new lesson that I'll be posting for you guys that'll be up then. You guys have been doing a good job overall of getting things in and reaching out to me if you need any help on anything. Please continue to do that and keep reaching out. And yeah, we'll see you guys later.